Hi. So today we are taking a binary tree problem. So here this problem is reverse level order traversal. As the name suggests, we are going to traverse the tree in reverse order. That is, we are going to print the nodes in reverse order, starting from the last level, then second last level, and like that till the root. So to start, I will create a node class to represent the node of tree. So it consists of a data variable and then left child and right child, and we'll give a simple constructor to this class. It accepts data. We'll initialize the value, data value, and to start with, the left node and the right node, both of them are initialized with null values. So here I'm making them null. So now our node class is ready. Now we'll jump to the uh, actual function to print the reverse level order traversal of binary tree. So here is my function, uh, reverse level order traversal. So what we are going to do in this function is, as this function will not return anything, the return type is void, and we are accepting a node. Basically, we are accepting the root node, and we have a base case here. If the root node is null, then there is no work to do. We will return from here itself. Otherwise, we have to do some processing, and what we are going to use here are, we are going to use two data structures. Uh, First one will be a queue of type node. So this queue will be used to store our nodes of the tree, and this is of type node. And the second data structure is stack. This is again of type node. So now our two data structures are ready. In the queue, we will add the first element, which is node, and then we will do the processing, the actual processing, to print the nodes. So we'll check if queue is not empty. So we'll do this processing until the queue is not empty. So even the queue can consist of single element. Till that point, we are going to continue this operation, and so we'll get the node out of queue. So this pole will get the node, and we'll push this element inside the stack. So the temp node is pushed inside the stack, and then we are going to check if temp node right child is not null. We are going to add the right child to queue. So we are going adding temp node dot right here, and if temp node dot left is not equal to null, we'll add temp dot left. So q dot add temp node dot left. So here you can note that we are adding first the right child and then the left child, and the stack, in the stack we will first uh, according to this insertion order in the queue, what will happen is first the right child will be inserted in the stack and then the left child. So what happens, the left child will be popped first. They will be, because we have to print like in this order from left to right, so that's why we will be pushing the stack from right to left. So that's why we are inserting first the right child and then the left child. And after this while loop, we have the complete, the stack now consists of all the elements of the tree. And what we are going to do is now print the elements of the stack. So here only we'll print the element of the stack. So until the stack is not empty, we'll print, we'll pop the element from stack, and this will be node. So node dot data we have to print. We'll give a space, some space, and yeah, our program is ready. So we'll pop all the elements from the stack and print it out, and then we are going to test this function. So I'll create a main method, and then say I'll create root, uh, so new node, and then I'm creating the same tree as shown here on the top. So for this I first need to create the instance of reverse level order traversal binary tree, and I'm calling it v tree is equal to new reverse level order traversal binary tree, and then we are initializing the nodes. So binary tree dot new node. So this is my first node, which is the root, and then the left node, the left of one is equal to uh, so new node, and left is 2. I will copy paste this thing. So left is 2, then right is 3, and then we have left is 4. So left dot left is 4 here, and left dot right is 5, and then the rights, left and right, we have to set. So root dot right dot left, which is equal to 6, and then root dot right, which is equal to 7. So now our complete tree is ready. What we are going to do is we will call the function to uh, print the reverse order of binary tree. So we'll pass the root here. Yeah, and that's it. This is done. I will run the code and see if this is working fine. So yeah, so now we can see the output. It's as expected. So first the leaf level nodes are printed, that is 4, then 5, then 6, then 7, and then level above it, which is 2 and 3, and then the final root node, the value is 1. So that's it for today. We'll meet in the next video. Thanks a lot.